Well, I know I've been a bit of a little Debbie Downer and a bit frustrated in my last few videos regarding this experimental strip thread repair, an attempt to put the threads at the top of the block as opposed to the very expensive manufacturer's recommended method that requires tools available from various sources, brand new, over $500. And when you search on eBay, folks are trying to sell these things for about the same price used as they were new. So I'm like, no, I'm just not doing that. So, anyhow, after I put that first insert in, was a bit it just didn't. It was wiggly jiggly going in, but then, and I'll show you in this video that everything's loose until you tighten it down. So, but looking at the numbers and stuff, yeah, the minimum diameter for the tap to use this insert is a little bit bigger than their designed and engineered minimal diameter. But I'm using an inch long insert, and after meeting with my engineering buddy, we I already got the parts. Scratched our head and just kind of shooting from the hip here, and said, there's a pretty good chance it's gonna work. So I'm gonna try it. I've already got all the parts. I got all that money invested in it, and after all this time and such, this has just become a quest, to see whether this experiment will work or not with what's available. Again, the frustrating thing is that the non-standard hole for that's already there above the threaded portion of the head bolt threads is 469 thousandths, and it's either a little bit too small or too big for anything that's out there, to thread out and put in, because you have to keep in mind the thickness of the water jacket wall. And another company that I'd found, Easy Lock, I couldn't get a hold of them to confirm, because with them you can use standard size taps, and I could use a 9/16 tap to put in their insert to take me back down to 7/6/14, but I couldn't get a hold of anybody, and there's nothing on the website that says, looking through their PDFs of specs and everything, that you can stack them. So I could get like an inch of insert in there, stack them like you can with a helicoil, or that they have them available, in any longer lengths. So, I'm frustrated over that too. So, anyhow, let me grab the camera and let's go take a look at some stuff down on the block. And actually, first we're gonna do some mock-ups with the bolt through the head and measure the depth of the bolt into the insert, all mocked up on the bottom of the head and such. So let me grab the camera and we'll go do that. All right, let me show you the actual time cert kit I ordered from these folks here. Here is the counterbore tool, and you counterbore it because of, and these are the 1/2 inch inserts that come with it. Here's the there's an insert, there's a 1 inch insert actually on the insertion tool. So you see I've had to wrap some tape on that. Not exactly precision machinist techniques, but it works in a pinch. The reason I'm having to do that is because the 29/64 bit that comes with this kit
which is designed to work with this tap and these inserts, turns out to be 453 thousandths. And as I've mentioned before, the Kia hole, the counterbore hole that goes down for the head bolts that I have is 469 thousandths. So you can see this is a wee bit smaller. It just kind of falls right in there, so we don't even use that. So here's the here's the tap, and I've got the dimensions on a piece of paper, and I think you've seen them in other videos, but we'll break that out a little bit later. So it does cut good deep threads. Just we're working now with a larger minor diameter than what this would drill out, so you don't get the cross section of what the teeth cut is just not quite as deep. Let's see what else. I think that's it on the kit. Again, I think there's an one insert on the driver. Oh, the counter bore, if I haven't already said, is because you've got this little lip that you have to make a little counter bore for this to sit below the deck surface. So all right, let's put this down and look at the head bolts, the washer, how far it sticks through, all of that stuff. Okay, again, this is an unproven experiment, so don't run out and go get all this stuff and say, oh man, this guy said it works, da 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 da. No, we are all in this together, and we're playing it by ear here, and this is trial and learning. But these are the bolts that I got. They are ARP fasteners, got them from Summit. There's the part number. These are small block Chevy main bearing bolts. And I also got this set of washers. Now the washer is it's 125 thousandths thick, so we lose an eighth of an inch, 125 thousandths going into that insert. But I'll show you in a second why I want to use that. And you can pretty much imagine yourself. Look at how much more area we're spreading. Let me put it behind this. We're spreading that load of that bolt out further, as opposed to it being focused under here. And then again, you're turning a steel bolt on an aluminum surface. It's just going to kind of mar and dig into it, and we want to avoid that. We want to make sure everything is pulled down clean and even. So I'm willing to sacrifice 125 thousandths of thread for this being spread out on the top. So there's our washers and bolts. So next I'm going to put the bolt in, and we'll measure the depth and mock up and insert and all of that stuff. All right, with the head bolt with the washer on it pushed through, and check in our depth here. I get 714 thousandths. And when I screw on, here's the insert, which would be down in the head. So when I screw that insert on, and then take this depth measurement here, I am getting 289 thousandths. And so the difference of the 714 thousandths from 1 inch is 286, and I'm measuring 289. So 3 thousandths between, you know, this measuring and so on and so forth. You know, there's going to be some margin of error. Anyhow, so that's what that looks like. Okay, so the other thing I did want to show was our proposed head bolt in this experimental insert attempted repair. I'm going to keep putting that out as a disclaimer. I want you guys to just wait and see. Anyhow, you can see there's still a lot more surface area that could be covered and that load distributed on. Now again, without the washer, I do gain an inch back of depth into that insert, but that, you know, that surface there, as we're turning and tightening, is going to be, you know, marring that surface, and we've got a more focused load point. So when we put the washer on, where are you? There we are. Here's our ARP 1/8 inch 125 thousandths washer, and now you look in there and you can see, wow, look at how it's essentially the same as the factory bolts, which I don't think I have one in reach here, but you know, they come with a captive washer, and that's pretty much how it looks on those factory very long torque to yield bolts. All right, so let me show you real quick how this insert goes in. Let me grab the camera and we'll take a look at that. Okay, we already know that the hole is bigger than the bit that comes with the kit. So we know that hole is 469 thousandths, and this bit is 29/64, which is 453 thousandths. So clearly smaller than the hole we have. So the major diameter from the widest part that these threads are going to cut across, that is 533 thousandths on this tap for the 7/16/14 internal thread time cert kit. It's major diameter when it taps. For the outer diameter of the inserts, this tap is going to cut 533 thousandths across the widest part there. And the insert thread OD is 520 thousandths. Going into that 533 thousandths OD major diameter thread cut. All right, so per the directions, I needed to go back and check this one more time, and we are counter boring first, and then you do the tap the threads. Honestly, I kind of thought it would have went the other way, but anyhow, counter bore. When counter boring, use light down pressure with slow to medium speed. Counterbore the hole to the full depth permitted by the tool. The counterbore tool has 4 cutting teeth and a larger diameter, which is the stop. When the diameter contacts the surface for a full 360 degrees, this is the full depth. When it goes when the stop is contacting the deck for a full turn, then it's done. It's not going to cut any deeper. So let me go back and check. I do have, it looks like it's about there right now anyhow. I mean, I'm doing this upside down so I can see the bottom of the how far it's going in, and it seems like it's about there. So maybe one more turn. And I was having to use the wrench since the this they have this just a fraction of an inch larger than the hole in the T-handle, so it will not fit in there by the teensiest weensiest bit. So again, I apologize, my arm is it is. So is it? Yeah, it's exactly right over it. So let me do this and I'll turn the camera back on. All right, so here's where we are right now. Putting the insert in upside down, it goes in there a lot deeper. If we look at the tool here, let me get it in focus. Okay, so there's the stop. That's when it hits the top of the block, and here's the insert. I thought this was going to be a much shallower cut. I'm going to go ahead and cut the threads now. Probably going to be in the way, and watching a hole get tapped is about as unexciting as it gets. So we'll start it here, and it is cutting and feels centered. So we'll just go ahead on down. Oh, the other thing I wanted to add, we'll see it when I pull the tap back out, is the fact that when that counterbore tool went a full 360 is with the stop touching the deck would be, when we're done. But looking at the little scratches, and that's why I went a little bit beyond when it started scratching, and maybe I'm not getting absolute pressure on there, but a portion of that top of the deck is not scratched, but I didn't want to keep monkeying with that. So, might be a little crooked. I don't know. We're going to see. So, all right, let me finish tapping this and then I'll pull it back out. And it's going pretty easy. All right, well, as you can see, it cut nice, deep, clean threads, and it had the right amount of resistance. Like, it was, cutting good and deep, but not, too snug in the hole, which we know it wouldn't have been. But here's what I was talking. I don't know if you I just want to keep the camera where it is for right now. You can maybe see, yeah, you can see, from there are little fragments of trace from here to here going around the circle. It is definitely contacting, so I don't know, 270, 280 degrees or so of the full circle. But there's some spots in here where it looks like this bottom stop did not touch, but I didn't want to keep fooling with it. Anyhow, I'm gonna go get my shop vac and vacuum that out, and then we'll put the insert in, and then it will be dark and cold and time to stop anyhow. oil threads of the driver tool using a few drops of insert driver oil or 30 weight motor oil, which I've got a lot of. Screw an insert onto the driver and into the prepared hole. While screwing the driver through the insert, the driver will start to tighten up as it expands the bottom few threads of the insert. Continue until the driver loosens up or you reach the mark on the driver tool you marked previously. This way you will not bottom the driver tool out in the hole. Remove driver repair is complete. So I'll be doing that right now, and I'm also going to put some of the thread locker on the outside of the threads of the insert. So I'm going to stop the camera, get all that ready, and we'll put this in before we run out of light. All right, well, here goes nothing. I've got the insert, I've got my driver tool oiled up, I've got the insert almost all the way. It's about where it stopped by hand, going onto the insert driver, and I've got a strip of thread lock down both sides. So let's see what happens. My head in front of it now, so a little uncertain as to where I should stop with this. And I want to get some light on that, so I'm going to stop the camera and get some light on that. I just want to see. It's just about stopped. It did loosen up, so I'll show you that. And the tool started to spin easily. So now I'm going to take it out, and that's that. So we've got one in. 15 more to go. Yay. Another thing to bear in mind here is that top lip of that insert is below the deck surface. So when we get a depth measurement on that, it works out to about 42 thousandths. So you subtract that again away from how much thread depth we have into the insert. It all matters. All right, well, hope you enjoyed this video update on the experimental head bolt repair method of putting inserts at the top of the block instead of the much more expensive way down at the bottom. Again, we need to wait and see how this all turns out. I got 15 more inserts to put in, which I can do now that it's not 6 degrees like it was last week. 6 degrees last week in North Georgia, so now it's 60. Anyhow, we're gonna have to see how this
this turns out, and it's going to be a while, we got still a lot more work to do to get this thing all back together, turn the key, and see what happens. But at any rate, if you enjoyed this video, grab your insert driver and twist down on that like and subscribe button. Please comment. Yes, please comment. Share. Like, subscribe, and let me know what you think. And I'll see you on the next one.